Hey, what's up, everybody? Uh, this is Jason here to talk about forecasting. Now, as a disclaimer, I'm not a meteorologist, so take everything you hear with a grain of salt, because most of this is just based on what I've learned over the years. But let's go ahead and get started. So I'm going to start by talking about the four ingredients that we need for severe storms. Three of those ingredients are needed just for storms in general, but the number one thing that we need is we need a source of lift. No lift, no storms. The number two thing that we need is we need some moisture. No moisture, no lift, no storms. And then the third thing that we need is we need some instability for some thunderstorms. Instability is going to give us the energy we need to develop the storms to a degree where they'll be thunderstorms and not just regular rain showers. And finally, the last thing that we need for supercells and for tornadoes, and to a certain degree, large hail, is we need wind shear. So those are the four ingredients that we're going to need in order to have the kinds of severe weather that I like to chase. So we're going to go ahead and get started here with the HRRR, which is what we like to call the HRRR. This forecast model is a short-range, high-resolution model, uh, and we are going to just kind of get right into it here. Now, the first thing I'm going to show you is the radar forecast. Now, this is for tomorrow, or actually later today. By the time this goes up, this will be out of date, um, but it'll be for the same day. I think I'm going to post this on Monday morning, which is the day of this event. But let's go ahead and do this. So let's go ahead and step through this. Keep in mind things that we need. Let's go ahead and step through this. And while we're doing that, keep in mind the things that we need. We need lift, moisture, instability, and wind shear. So to watch these storms, there's two different areas, actually three different areas of storms that we're going to be looking at through Monday. We're going to stop once we get to like midnight, which is like 07Z, or maybe it's sooner than 07Z. But anyway, we're going to stop once we get to midnight. But notice this complex of storms down here, and I forgot to start my pen app here. So let me start that up real quick. Let me find it. It always goes where I don't want it. Okay, let's use, wow, this complex of storms right here. We're going to focus on this one for right now. So notice that it comes out over Mexico and kind of makes its way into South Texas, into Central Texas there along the 35 corridor, and then continues on. Well, why do we have storms there? Why is this forecasting storms there? That's the question that we need to answer. Now, we're doing this backwards, but I'm doing it backwards for a reason, to kind of illustrate what's going on. So let's go ahead and stop it at 21Z, which is a pretty good time. So 15, we'll click on 15 here, and then we'll have a little complex of storms. Now, let me erase or delete the drawing. And I'm going to scroll down to get that there. Let's draw a circle. Actually, let's cover this whole thing right here. That's the area we're going to focus on. Let's go ahead and look at where we would normally start. So let's go to the 500 millibar. And notice what we have here in the 500 millibar. We have this little short wave, which is this line right here. This little short wave is coming out of Mexico. coming into south central Texas. This is providing us our lift, our area of lower pressure that's going to allow these storms to form. Now, this is going to propagate towards the east as time moves on. So notice it's there, and it's moving. And as this moves to the east, the storms are going to kind of move along with it. But let's go back to the beginning here. Well, at least where we're starting at. The next thing that you need is you need some moisture. If you don't have any moisture, I mean, there's just nothing going to happen. Well, we've got lots of moisture. Moisture here is shown in the form of dew points. So the darker and purple colors represent more moist air. Of course, over the Gulf of Mexico, they're really high. And over here over the desert, they're really low. But right in here, this area is where our shortwave is. So because we have enough moisture and because we have that shortwave coming through, the HRRR are saying there's going to be some storms right here. Now, can we rely on that? We have to look at multiple models and look at our experience to kind of know, is this actually going to happen? But right now we're focusing on the dynamics of what creates this weather to begin with. You know, if we're theorizing here, saying, okay, this particular model is, what if we think this is what's going to happen? Is this going to be representative of what happens later today? So, and that may or may not be the case, but bear with us here, or bear with me here. So let's erase some of this. Let's redraw our little area. And then let's look at the next thing. We have our moisture, we have our source of lift. What's the next thing that we need? We need instability. Now, you can look at that in several different ways, but I'm going to go with the one most people use, and we're going to go with surface-based CAPE. Now, as you can see, let's use a different color here. A lot of this CAPE is displaced up here, but there is a little bit right here, and there's still quite a bit here too, but it's a lot higher out here. But there's still plenty in this general vicinity for us to get storms. So we have instability, we have moisture, and we have lift. Well, what's the last thing that we need? We need some wind shear to have any kind of severe storms. And although wind is one of the exceptions, you don't necessarily have to have wind shear to have strong winds, but that's another story. So let's go ahead and delete some of this. Go back to our cursor. Let's look at wind shear and see what it looks like. Now, there's different ways to look at it. I'm going to start by looking at the 850 millibar winds. This is the low-level jet, and there's really not a lot going on here in our area of concern. Remember, this general vicinity here, right in this area, was where our storms are. But notice there's not much of a low-level jet in this area. As a matter of fact, there's not really much anywhere. Even here, it's relatively weak in these little areas here. So there's really not much of a jet to really kind of get things going for us as far as severe weather goes, or at least as far as tornadoes go. So the tornado threat based on this is not very high. Let's go ahead and click through and see if it improves at all over time. And you can kind of see over here it improves a little bit, and over here it improves a little bit. But if we go look at our actual reflectivity, it's improving in areas where there's not necessarily going to be weather. Let's go back and let's draw some lines around where this weather is, where these storms are. Let's see if there's any overlap with our low-level jet. There's a little bit here, a little bit here. We'll just do that for the fun of it here. Let's see if there's any overlap. Let's go ahead and go back to the 850. The only real overlap is way up here. Now this is 0 to 1 kilometer. I mean, let me start over. This is the low-level jet. So that's going to play a little bit of a role as to what kind of storms we're going to have. And if you look at the, notice how messy it is. Even up here, it's relatively messy. Now, up here where there's somewhat of a jet, you do have a little bit of a helicity track, which is this little black line right here. But let's take a look at our SRH, which is what we're going to see with our wind shear. Now, notice that this wind shear is displaced from our storms. Now, up here, it's displaced as well, but there are some little pockets up here, which, in my opinion, is why they're probably giving this a 2% tornado risk. If we come over here, let's delete all of our drawings and go back to day one. They are giving a 2% for this general vicinity. But notice they didn't give it up here. There's no 2% risk up here. And let's find out why there's no 2%. And I can already tell you it's because of a lack of moisture. If we go back to the dew point, these dew points are in the 50s, low 50s up here. And so it's going to be real hard to get any kind of tornadoes with dew points that low. And so the focus is in this area where there is moisture. And if we were able to overlap the risk area, which actually I think we can go ahead and do that real quick. Let's show you the day A1 tornado. Let's draw. All we have is blue, I guess. So let's draw that. Kind of try to outline this as best I can. That is our 2%. Now let's go back and look at our forecast models. Notice that this is kind of where the best moisture is. And if we go down, well, that's fine. Let's look at our reflectivity. Notice this stuff up here is outside that 2% risk. All of this stuff is in the 2% risk, and that's just because of the moisture content. Even though we have a decent low-level jet up here, there's just not enough moisture up there. So let's look at another thing. Now, these are really helpful. Let's look at bulk shear. Now, there's plenty of bulk shear in this area, which is another reason why I'm thinking of probably putting the 2% in there. Just because there's plenty of bulk shear there. It's just, where is that wind shear? Let's look at SRH again. And you can see there's some here, there's some here, and there's some here. And I think that the reason why this is drawn the way it is due to uncertainty of where this stuff might occur. There's probably more certainty it's not going to occur over in these areas as opposed to in this area. So that's kind of leading me to believe that I'm putting in a low-end tornado risk because there's an outside chance you might see a tornado if you get lucky. And then finally, I guess we can look at some of these other parameters where our energy helicity index, which is an index that combines surface-based CAPE and storm relative helicity at the different layers, basically combining energy and wind shear together into a single value. And notice it's kind of spotty. It's not really widespread. And so, yeah, you might see a tornado, but it's probably pretty unlikely. But the other thing we can look at is significant tornado, and it's even less. There's still pockets of it around, particularly up here, and maybe a little here, but more so up here, which probably if you're going to be, if I was going to be targeting this, I'd probably pick this area here based on all of the information that we have. And let's go look at moisture because that's really important. But this is kind of near the cap rock, so higher elevation but lower moisture, you can still get a tornado. Let's take a look at the dew points. They're in the upper 50s here, whereas over here they're in the mid to lower 50s. So this, I think, would be enough, especially with this being so close, these 60s dew points here. I think there could be a chance of seeing a tornado over here if we get storms in this vicinity. Probably this entire, just due to uncertainty of where this will occur, I'd say this whole area right here would be my target. Except for maybe right here, you could just kind of scratch that because that's just not going to happen right there. But this area right here, that's where I would probably look for tornadoes. Um, Down here, which is closer to where I live, it's got a lot more moisture, but the storm mode is really messy down here due to wind shear not being very good. So that's kind of how I forecast these things. This isn't a very good setup to look at, but it gets the job done and shows you kind of how we do this with the different um, parameters that are needed. Uh, Lift, moisture, instability, and wind shear. One last thing I'd like to look at before we finish up the video. Notice, let me clear this out. Notice this little short wave up here. So because of where the HER is forecasting this short wave, this would probably be my target right here. And well, how do I know what it is? Well, one of the things I like about Pivotal Weather is you can kind of click on it and it's got a marginal tour there. Notice how this, even though the dew point's 59 degrees, look at how high up this is. Uh, Notice that this is here instead of down here. Typically, you'll see it down here. But because it's up here, the lower dew point is actually not as big of an issue. So you could see a tornado in this area. This isn't a very good CAPE profile. It's very long and skinny. So they won't be super explosive updrafts, but there's enough here for a weak, short-lived tornado. And this kind of says the same thing as well with the hooded graph over here. These are things that we'll have to get more into in probably a separate video. But that's basically what I would look at. Let me show y'all one more trick that I like to do. And search. Let's put this. Let's get rid of all my drawings. So Dimmitt. Dimmitt, Texas looks like Dimmitt, Hereford, Freonia. I would say Hereford or Dimmitt would be my target for later today if I was going to be chasing, because that's the general area where this is going to be occurring. Uh, so that's pretty much it. You have this little shortwave embedded in here, and you have this one here, and you got this one up here. These are going to be your sources of lift. Uh, it's not a real strong system since we're having to rely on these shortwave troughs embedded inside the lower portion of this longer uh, pattern here. But that's what we've got. It's late May, or it's getting into late May, and it's just a really strange pattern. Hopefully it heats up here. If it does, maybe I'll do another video about how I do the forecasting. Uh, but for now, I appreciate everybody watching. This is about 20 minutes long now. And if you have questions or comments, please feel free to put them below. If you have any insight, if you have better advice for me or whatever, please feel free to go ahead and leave a comment with that critique or whatever down below. Thank you, everybody, for watching.